This reaction says, identify the reagents needed to carry out the following synthesis. So let's take a look at our product and the different reagents that we have. In this instance, it's important to kind of draw in the alpha bond and even in this case, the beta bond. And what we can see in our product is that we have a pi bond between the alpha and the beta bond. And this structure, this alpha beta unsaturated ketone is very indicative of an aldol condensation reaction. So in this case, we know that we probably started with two molecules that were separate. I say that because the structures of the product are very kind of different looking. If we break apart our alpha beta pi bond and work our way backwards, we can see that the aldol addition product looked like this. And then if we break that alpha beta bond further, you can see that we use this enolate and reacted it with this aldehyde to get to that aldol addition product. So because we had kind of two different reagents, I know that this was a crossed aldol reaction. And our first molecule was cyclopentanone. So if we think about the synthesis, this makes sense. The LDA is a strong base, and it's used here to kind of minimize the amount of multiple byproducts that you could get in a cross aldol reaction. So by first making the cyclopentanone into an enolate and then adding in the aldehyde, we kind of limit the amount of enolate intermediates that we can form. So that's why we have LDA first. And then 2 is this molecule right here, our aldehyde that we added in. And then the H3O plus would help to kind of favor the condensation reaction. So in this case, if we're to solve this question, think about what reagents did we need? We needed cyclopentanone, which is 2. And then we needed an aldehyde, which is molecule 3. By adding 2 and 3 together, we get answer choice B, and that gives us the condensation product that we formed here. A couple of questions I often get: how do I know that I had an aldehyde right here and not, say, a ketone? I knew I had an aldehyde because if I look at my beta position, there's a hydrogen right there, and that's the hydrogen of the aldehyde. Next up, you can kind of think about, counting carbons. Sometimes that can be a really beneficial way to eliminate other possible answers. So like 4, for example, we can eliminate because it has an extra carbon than our structure would. So that helps us to kind of eliminate 5 as a choice. You can think about eliminating your answers in that way, and then kind of work your way backwards like we did to figure out what the starting materials were.